Yeah.
7:30. So we'll be sharing a final link of the result announcement by today evening or tomorrow, where you can join for tomorrow's session. Okay, and we will be announcing all these details today. So wishing you all the best. Looking forward to some really cool solutions and seeing what you guys have done so far. So over to you, Prajwal.
Yes, thank you. So what we'll be having in this session is that we'll start with the projects one by one. You can share your screen and present your report. And by your presenting, you can go through your project as per the video you have prepared. If needed, you can add a few things here and there, and we'll judge you on the presentation skills as well as your project skills. And the final marks and everything will be given to you tomorrow when the results are announced. So I hope everyone's clear with how we'll proceed. Uh, I guess yeah. So I guess we can start with Gyanvi and Ankit first.
Okay, sir. We are sharing screen.
Yeah, sure. Go ahead.
And yeah, if all of you can switch on the camera also, that would be helpful while we could see.
Yeah. Please turn on your camera.
Sir, I hope our screen is visible.
Yes, it is.
Thank you, Ankit. It is visible. So, sir, I'd like to start. Good evening, the panelists and all my fellow friends present. So, before starting, I'd like to thank Capable, that is from Elite Techno Group, for organizing this competition. It was a great experience. And now, starting with the project, the following project was performed under the ICE Challenge 2022 by Ankit Khatri and Gyanvi Bhardwaj, that is myself. So the problem statement is to perform battery pack calculations for 530-kilometer range when the following parameters were given. So the assumed parameters include the cell form factor and the terminal voltage of battery pack, which is 360 volt in our case. So the next slide will depict the softwares that we have used to carry out the project. These include Microsoft Excel, SolidWorks, and MATLAB Simulink. So the next slide will be about the Excel calculations, which Ankit will explain. Over to you, Ankit.
Thank you, Gyanvi. Good evening, everyone. Myself, Ankit Khatri. I am the team member of this group. So the parameter that we have given in the problem statement was the range of vehicle and the energy consumption of the vehicle. That is 530 kilometer and 77.4 watt hour per kilometer. For calculating the overall energy dense content required for the battery pack can be obtained by multiplying the range and the energy consumption that we got near about 41,022 watt hour in our case. For dividing the battery pack into the series and parallel connection, we need to have some motor or the load voltage. So we have assumed that the battery need to be provide 360 voltage. So according to that, from the calculation, we have received the battery capacity that is obtained by energy content divided by the battery voltage, that is 113.95 Ah. So these are the steps that we followed for carrying out the or selecting the cell composition. We have given 5 types of cell: Panasonic cylindrical, A123 cylindrical, Molicel cylindrical, A123 pouch, Toshiba pouch. So these are the given parameters that we have obtained from the table, and after that we have used and calculated the different parameter of the cell. For calculating the total number of cell, we directly divide the energy content of the battery with the energy content of a cell. So we got near about 3561 cell in the Panasonic cell, 4973 in A123 cylindrical, and 4265 in Molicel cylindrical, and 638 in A123 pouch, and 891 cell in Toshiba pouch. So from this we can directly see that the minimum number of cell required is 638, which is of the A123 system pouch cell. After that we have calculated the battery pack mass. By multiplying the total number of cell into the mass of one cell, we get the battery pack mass that is coming about to be 316.45 kg in our A123 system pouch. And the battery pack volume that we have obtained is by obtaining the volume of per cell, that is multiplying the height into width into thickness of the cell, and we get near about 168 liter. There is one assumption that we have made while using cylindrical cell. This is a theoretical value that we are obtaining in the Panasonic cell, that is 62.5. It seems to be very low volume, but when we pack the cylindrical actual, there are always some voids in between the circular portion of the cell. So that's why when we have calculated the actual by taking the diameter of the cell, that comes out near about to be 400 liters, that we have not mentioned here. But according to seeing to the battery mass and the volume, we have got the best packing efficiency in the pouch cell, that is A123, and it is also providing us the peak power of the battery near about 410 kilowatt, and the peak battery continuous power is near about 41 kilowatt, that is required in our problem statement. And by this we can run the vehicle near about 530 kilometer of having energy consumption of 77.4. After that, we matched our calculation with our MATLAB model also. This is a MATLAB model that we had derived. I think the picture is clear, or else I will show it in the Simulink model. So we have put all the given parameter in the constant block, and after that we had applied the different formulas and the mathematical operation, and then we have got the result in the display block. Some go to and from block are also used in the MATLAB Simulink, so as to maintain the symmetry of the MATLAB Simulink model. It look nice. So at all the parameters that we have obtained, the value of the parameter that we have obtained in the Simulink are matching with the Excel sheet calculation. It means our MATLAB model is also working fine, and we have selected A123 pouch system. We have also designed the CAD model of the cell, that is taking the original dimension 22.7 mm, 16 mm, and 0.73 mm. Then we have designed an assembly of the whole battery pack that we have calculated. Here we are near about 638 cell, and we have joined 110 cells in series and 6 in parallel to fulfill the output requirement of the battery. Why we selected this type of cell? Because less number of cells are coming out to be, and pouch cell have a good packing efficiency. They comes out to be a high peak current also. Their battery mass and volume is also low. They have high specific energy and good thermal stability. So the conclusion of our project is the number of cells required for the battery pack in case of A123 pouch cell is significantly less as compared to the cylindrical cell and the Toshiba pouch cell. Battery pack mass volume is also low as compared to the other types of, and they provide a better packing efficiency. Pouch cell have a high continuous peak current and a power delivery, maximum discharge and maximum peak discharge current also. A123 system pouch cell offer additional advantage like better thermal stability and safety based on the calculated data, and hence A123 system pouch cell have been used for EV battery pack design. Now I will show you our Simulink model if it is not visible in the PPT. This is the model that we have created. So we have put all the given parameter in the constant blocks, and that apply the different mathematical operation for finding out the actual. This goto block is also used to send the value from value to the from block, and we got the volume energy density, gravimetric energy density, cell continuous current, battery peak power, and battery peak current, and cell peak current. These all values we have obtained on our MATLAB model.
Okay. So yeah.
Thank you.
Yeah, it was a very nice presentation. Could you let me know, Ankit, what was your contribution in this project and what was Gyanvi's contribution in this project?
Yes, sir. So actually, Gyanvi had been doing the calculation on the Excel, and we both were in the same college. So we sat down in a classroom and we done all the calculation by ourselves. And formulas we derive and try to thought from our all theoretical knowledge. And we have used our project guide also for this. And Gyanvi has also helped in making the video of this presentation. And I have made the MATLAB model and the Excel sheet.
Okay, okay. Let's go. So, yeah. So, did you just refer to the presentation that we provided for the cells, or did you do another extensive research? Let's say, instead of the recommended cells, you went and you saw, would there be any other cell composition used for this project or anything like that?
Sorry, your voice is breaking. Can you repeat?
Yeah. So what I was saying is when you were selecting the cell, right? Which cell composition you would go ahead with. Did you do any other research apart from the ones that we provided in the PPT, right? We gave you a few examples out of which you selected one. Did you do any other research as to which other cell composition could be utilized or anything like that?
Sir, yes. So actually, we have also selected the Tesla cell also, but we thought that we have to select amongst the given cells on the sheet.
Okay, no worries, no worries. Yeah, that's all right. So, Umang sir, do you have any questions? I think.
Yeah. One thing I would want to understand from the team is, so you have mentioned about the efficiency of pouch cells versus cylindrical cells. Are there any particular situation which might come because of which you would consider cylindrical cells better than pouch cells, or would always you consider pouch cells over cylindrical cells?
No, sir. Sir, actually, these depend on the situation. Like the pouch cell basically have a fixed geometry when we pack them in a module, but cylindrical cell offers the benefit of filling the spaces in between, like when we have to convert a vehicle. So if we have to put the battery in a fixed space, or the like, that is not changeable. So here we use cylindrical cell also, where the space is low and the geometry is not so even. When we pack the pouch cell, these are to be fixed in a proper length, breadth, and height, and whereas the cylindrical cell can be put in a less space also.
Got it. Cool. So that's all from my side. Yeah.
So thank you for your presentation, Ankit and Gyan. It was a very nice presentation. I guess you all are comfortable presenting and everything, so that's why it was easy for you. So yeah, even I don't have any further questions. I think your research was pretty extensive as to why you are using the pouch cells over cylindrical cells. So moving on forward, Samrat, if you could present your project and present.
Thank you, sir.
Yeah, thank you, thank you, thank you, yeah.
Okay, thank you.
Hello.
Yeah, Samrat.
Okay. Actually, I'm the only one present from my group. Actually,
Yeah,
my partner was unfortunately my partner was not able to join this session.
yeah.
Okay. Let me just share my screen.
Samrat, and if you can also switch on the camera, that would be great.
Okay, but the problem is actually the electricity is gone at my side, so I am joined by my by mobile. So
Yeah, I can.
okay, I'll try to switch on, but if there is internet problem, then I might have to switch it off again.
Yeah,
Sure.
Okay. So this was the problem statement given by you guys developing the battery pack. The requirement is so the requirement was to make the battery pack for the range of 530 kilometer with the power average consumption of 77.4 kilowatt watt hour per kilometer. So that was the problem statement given. And according to it, I have done my calculations here. So the first of all, we calculated battery pack capacity, and which were calculated by using the formula, which give us the 41,000 watt hour, but I have considered something greater than it. Means I have considered for 42,000 watt hour, but actually we all know that we can only use the 80% of the battery capacity. So that's why I will be designing for the 52.5 kilowatt hour. Means actually the 80% of it will give me my actual usable battery pack capacity. So that's why I have taken the 52.5 kilowatt hour. So from I have done some rough calculation, and from that I have considered directly only two cells. One is Panasonic cylinder, and 123 A123 system pouch cell. Actually, I was on A123 pouch cell because in the pouch cell it is having the greater cell capacity of 19.5, and cylindrical cell because I directly found that I directly find it best among the all which were all which were given by you. So I selected them. I compared the data and calculated calculated all the required data using this formula, which I have, and then after I have we selected Panasonic cylindrical Panasonic cell. The major reason behind selecting the Panasonic cell is only because of the mass and volume of the battery pack, which was going likely to be double than the pouch cell. Actually, my concern was not about the C rate. Actually, the peak pouch cell will be giving the peak current, which was battery very high current, but that is not of use for the general use car. It can be used for the cars which when we require the much high power, but it is not the case in general. For the general means we sedans or the cars we use regularly. So considering that point of view, I selected this one. The voltage of the battery pack I have considered around. I checked it online, and by doing the research, I come to around that we should select the voltage around 400 to 800. That is the not appropriate, but the average amount of cars use the range of the voltage from that point of view. So I have kept my battery pack voltage around 420 voltage, and according to that I draw my data. This is the calculation which I have done, and then after I prepared this report. So our objective again, the same objective, which calculating a battery pack for the 530 kilometer, proper selection of the battery cell. So again, cell selection I have already described that why we selected the two cells, and from these two cells only because of the battery pack weight, mass, and the battery pack volume, I have considered the Panasonic cylindrical cell. And here's the MATLAB calculation, which MATLAB model which we have prepared. Actually, I can show this here. And it is simple model. I can do after the calculation of the in the rough calculation, I have done. I have put my specification here and directly calculated the required, and we can get the more than what we have required. We have taken the we got our range more than that actually. So, and the number of cells which are required are one total number of cells which we require 4,563, and distributed in 39 models, 39 models in parallel, containing 117 cell each, which will be battery pack will be having 221 kg and the volume of 80 liters. So it is more than perfect, and it is the small means I consider this as the best, means we can get best model battery pack which we can get for such a light mass and also the volume, because that was the main problem here. That's all. Thank you.
So, yeah, I guess your assumptions and calculations are pretty accurate. When you're designing a car, your basic motto is to comprise your battery pack as much as possible. Even though your number of cells are higher when compared to a pouch cell, the number of the size of the overall battery pack is largely reduced. So that's a big up because if the size is pretty less, I guess you can move your battery around pretty easily within the vehicle if you have some dimensional constraints.
Yes, I was going to consider the pouch cell. That's why I compared them both, and that I got to realize that it is better to have the means. If we design the pouch cell, we are getting the same result, but only advantage there was we are getting higher C rate. But the having higher C rate is not that means if we are not designed for sports car or something
Yes,
that we
yes,
require
yes.
such a high ampere per hour. So that's not my concern.
Yeah, exactly.
So we as in by normals, yes, that's why I'm considering.
Yeah, since Kia is more of a commuter instead of a performance car. So I guess your design is pretty practical and your front design looks a lot less clustered since you decided to integrate a few calculations here and there in comprised the design. It's a bit more sophisticated. Presentation skills would also be worked upon. I guess it will take some time. But apart from that, I guess
Sorry.
yeah, your presentation skills could be worked upon a little bit, but apart from that, I guess your design and
Oh yes.
yeah,
No, actually, I was expecting my light to be good, and my internet broke down just before the
Yeah,
5 minutes of this session.
Yeah,
So I was arranged this so early.
yeah, I understand. Even I have been through this, so it's not a big deal. Yes. So, sir, do you have a few questions?
No, Sajjad, I think we are good. Thanks so much.
So,
Thank you, sir.
so before moving on forward, Samrat, could you tell me what was your contribution in the project and what was Intuja's contribution in the project? Hello.
Can you
Yeah.
repeat the question?
Yeah, so
You were
I
not
just
audible.
yeah, okay. So I just wanted to know what was your contribution within the whole project and what was Rutuja's contribution to the whole project.
Okay, so actually, she's my she's my colleague actually, and I've designed and I've shown her the calculation that we that's what means actually we can do that for the calculation of the A123 systems. She has calculated all that, and I have done all this stuff majority because I have done the your program one nanodegree program sir, of yours regarding the electrical. So I have the majority of the knowledge of it, so I have taken out the project from her, most of it. But the regarding small, I got her to design for the A123 pouch cell. The calculation she has done.
Okay, okay. So that's good. So yeah, I guess Shankar, I guess you can go next, and then we'll continue. I
Can I
guess.
turn off my mic?
Sorry.
Thank you.
Yeah. So, Samrat, you have to do. Shankar, if you could start with your presentation. I guess Shankar has some network issues. Okay, in that case, then we'll proceed on with Colin. If you could proceed with your.
Yes, good evening, panelists. Me and my friend Agam here will be presenting. Agam, if you can present.
If you could turn on your camera, that's
Yes.
Yeah.
Yeah, you can see me, right? Okay. So, according to your problem statement, we had to build a battery of a battery which can give a range of 530 kilometers for a Nexon EV. Okay, so we've started here, and Agam here will give you an introduction about what we have done. So, if Agam can continue.
Yeah, hi, thank you. Hi, esteemed panel and my fellow challenges at the ICE 22. Thank you so much, Elite Techno Groups, for bringing this to us. It was really fun working on this whole event for the past week. And so, to continue with this, the challenge, myself, my name is Agam, and my project partner, Colin. We are both from Dayanand Sagar College of Engineering in Bangalore. So the problem statement for the challenge was to calculate and design a battery pack using the tools MATLAB and Excel sheet. So how we have proceeded through the whole thing, what went on, we started with the problem statement. We understood the softwares a little bit because we knew how to use them, but to a point where we can actually analyze or design a battery pack, we got into that. We did the manual calculations after doing some research and determining what could be the better options for these things. We understood the whole working of the battery pack. We designed it using Simulink and MATLAB tools. Finally, we came to a result which gave us a conclusion. And after having all of these things with us, we eventually formulated the report for the challenge. So with the calculations part, Colin will take up. Colin?
Yes. So I didn't know that everyone else here was just comparing batteries. So I went on about choosing a battery from the Tesla, right? 21700 lithium NMC. So these are the specifications that I got from the website, that is that robo.com. Yeah, robo.in. Okay, so each battery costs about $500. So I thought it would be cheaper. Next slide. So, okay, the resolution might be bad, but if you give me a link, I can share the whole MATLAB sim model and Excel sheet to you all. So what we calculated was the total battery pack energy.
Agam, can you just zoom in into a bit? On the bottom right, there's a zoomer. If you can zoom in.
No, this is a screenshot of the this one, Excel sheet.
Screenshot of that thing.
Okay, this is a screenshot. Okay.
Yeah.
Okay.
Okay, so as you know, EBC is what your current into voltage, 5 amps. Go to the previous slide, 1 sec. So you can see 21700 means 21 is the diameter, 70 is the length of the battery, a single cell. Capacitor is 5 amp and voltage is 3.6 volts. Nominal voltage of the battery pack is an assumption for 400 volts. Okay. Now, if you multiply the capacity and voltage, you will get the battery cell energy, which turned out to be 18 watt-hour. Next slide. Then VBC is volume, that is 0.0254. UVBC is volumetric energy density, that is 707. Gravimetry density is 257.14. Yeah. Okay. Number of cells in a string, that is series, is 112, and the number of strings that are present in the whole battery pack is 21. What I designed was a 6S56P battery module, and if you add 7 battery modules, you will get total number of cells to be 2352. That is modules, number of modules is 7. So the total battery pack series energy is 2016 volts, 16 watt hour. Then battery pack energy was 42.34 watt hour. CBC, that is battery pack capacity, is 105. Mass of the battery pack turned out to be 164 kilos, and the volume turned out to be 59.85 liters. Then your battery pack peak current, your battery pack peak power, that is your IBPP and PBPP battery pack. So 315 and 126 respectively, and your continuous current and continuous power of the whole battery pack turned out to be 105 and 42. Okay, next slide. This is my battery pack model. So this is a 6S and 56P battery pack. This is one single module. If you have 7 modules of this kind, you will get a what do you say, the current output to be around 2016 watt hour. Okay, nothing else. Next, I guess. Yeah, I guess Agam explains from here.
So for the cell selection, we have come down to choosing 21700 lithium NMC battery cells, and to go ahead with why did we choose it? Answering the big elephant question in the room: how is it better? How is it optimized? So basically, the battery density will increase. Increase in density means little volume and more power you get. The brief details about all these points have been given on screen, and I won't go on to the numbers, but yes, to tell the second point, which is the battery price decreases by 9%, which is a significant decrease. And the research that we did and the references that we took were from Tesla, for an example, and where we revealed that 9% price decrease will happen if you use these 21700 lithium packs instead of 18650, which was traditionally used in the same. Price differences are shown on the screen. It's 155 against $185 per kilowatt hour. To more go ahead with, there is a significant decrease in the weight of the battery pack. So your total battery pack weight will increase by a massive 10%, which means that you'll be packing more energy in a smaller battery pack. Not only that, your whole car weight will increase, increasing your car mileage and their better performance overall due to these three parameters, which is increase in battery density, reduce in price, and reduce in weight. So for concluding, Colin, can you take up?
So as you all know, there are many EVs coming into the market right now, but we are not getting enough batteries for that. Now we have seen recent talks with African nations to get lithium in India. So what we suggest is correct evaluation and best strategies to procure the raw materials will reduce the, what do you say, cost of battery pack in the future, which can be analyzed and used properly. Thank you.
Okay. So yeah, it was a very good presentation. I liked it, and your reason for selecting this composition is pretty nice, and not like you went ahead and selected a very different cell composition from the given ones, and you did your research and you compared. So while you were researching, did you guys compare it with apart from the 18650 configuration? Did you compare it with the given cell compositions that were given to you as a recommendation? And what did you find out?
So I didn't compare it with the way I compared it was cylindrical versus a pouch.
Okay.
Okay. Now, if you consider a pouch, it might be beneficial in some areas, but the weight increases.
Yeah.
Okay. But with cylindrical, the weight reduces. So there is a research which shows significant reduction in weight, around 500 kilos reduction in the whole car's weight. That is 1/3 of the car weight almost. So I thought, why not use lithium ions?
Yeah.
Better available also. Availability is more.
Yes. Yeah, very good.
Yes.
Yeah. Okay, so I guess it was a pretty good presentation. Umang sir, do you have any questions you'd like to ask?
No, I think good with this. And also, there are some questions which are being asked on YouTube. I think we will take those up in some time.
Yeah.
So that's it. Oh.
Okay.
Yeah. Thank you, Colin.
Thank you so much. Thank you so much.
Yeah. So Shankar, if you can go next. If your internet issue is sorted.
Can you hear me?
Sorry, could you repeat?
Can you hear me?
Yeah. You're audible.
Okay. Sir, can you see my screen?
Uh, your screen is not visible right now. Could you confirm if you have clicked on share at the screen?
Yes, I'll click.
No, your screen is not visible. Yes, it's a technical issue. You can check again, Shankar, and we'll have your presentation later. Rohit, if you could present your screen, Rohit.
Yes, sir, sure.
Yeah.
Yes, sir, my screen is visible. Is my screen visible, sir?
Yes, your screen is visible, Rohit.
Okay, sir. Let me start with my presentation. I'm Rohit More from Rajaram Bapu Institute of Technology, Sangli, and I'm going to present my Simulink model for the battery pack of 530 kilometer range and average energy consumption of the battery pack for 7.44 kilowatt per kilometer. Okay. The calculations that are shown here are done by me by doing the manual calculations by hand calculations, and that I confirmed with my Simulink model. As you can see here, the total battery pack energy that is counted is 41 kilowatt hour nearly, and the total cells in the strings are 122, and the total 6 strings are used. That makes the total of 732 cells of A123 systems. So here are some parameters that we have calculated, that I have calculated by using the MATLAB Simulink model. The mass of each cell is 0.469 kilogram, and that makes the whole battery pack as 362 kilogram. As we can see here, this is my Simulink model, which I have divided in 4 major parts. And this is the script where I wrote all the variables that that we require for the simulation of battery pack. Here, height, width, the thickness, and the weight, average, and range are the variables provided in the Simulink model. So this is first part of my Simulink model, that is cell specifications, which are derived, which we have declared in the MATLAB script. The second is the battery sizing area in the red, where we use the battery variables and calculated the total battery pack energy and the total number of cells and the total capacity of battery pack in amp hour. This is second area, which is shown in green. This indicates the battery power and the current calculations. So the total continuous battery pack power and peak battery pack power are shown here by doing some calculations. This is the third area of my fourth area of my calculation, that is mass and volume calculation part. Here we calculated the total volume of each cell and the total volume of battery pack, and thus the mass of battery pack as well. It might be not visible in the PPT, but I can show you my MATLAB model after the presentation ends. The cell selection and the reasoning. The selected cells are A123 power cells with the capacity of 20 ampere. Because they are very high, they have very high energy content and high capacity compared to cylindrical cells, and they make the compact battery pack with the higher density and high power capacity. They are very easy to module and very easy to maintain, as they can be put together in
3 of pack or 6 or pack. The cells manufactured by A123 have a very high maximum continuous discharge current and maximum pulse rate, maximum peak discharge current. As for the energy capacity, the power type cells have high peak current and the power than the cylindrical cells. That's why I chose the A123 power cells. So to conclude the presentation, the power cells of A123 having 20 hour capacity is chosen for their advantages over the cylindrical cells, and 732 cells are used in the 122 per strings, and 6 strings are used. Battery pack of 41.022 kilowatt hour is designed for the range of 530 kilometers, and hereby volume of battery packs volume of battery is approximated at 0.1275 meter cube, and the mass of the battery pack is 363 kilogram. If you don't mind, I will share the screen with my MATLAB presentation. Okay, sir, is my screen visible again?
Your screen is not visible right now.
Not yet.
Okay, I'll try again. Is it visible now?
Yeah, it's visible now.
So this is in the violet area. I have declared all the variables that is declared in this script, MATLAB script, as you can see here. And by using this, we have calculated the battery pack calculations and calculated the battery pack, and then the capacity of battery pack and total number of cells in strings, and the total number of strings that we have used. So the total battery pack energy is 41.022 kilowatt hour. And when we move to our third area, that is the battery pack power and current calculation. We have calculated here the peak battery power, battery pack power, and the continuous battery pack power with the continuous and peak currents. And fourth and final area of my Simulink model is the battery pack volume and cell calculations. Here we calculated the gravimetric and volumetric energy density of cell and the volume of battery pack with the mass of battery pack as well. So thank you, sir. Thank you, panelists.
Yeah. So when you selected this composition, which is A123, was the cell capacity and the power output the only reason while you're calculating, or did you consider the fact that cell weight might also be a huge factor?
Sir, I have considered the battery density and the power density in that as well, but when we consider the power cell, that might help us in the maintenance, and we can use that for good maintenance. And if the battery is short, or some cells are of their end of the life, we can change the whole model of 3 by the bare minimum cost.
So maintenance cost was also a key factor when you did. Okay, that's fine. But if you would have, let's say, selected a cylindrical cell like Panasonic or something, your overall mass would have reduced greatly, right? Your volume would have reduced greatly. So when you're designing a vehicle, the first factor is to have a vehicle which gives you more mileage, right? Better mileage in a country like India. Outside India, yes, various other factors come in, but in India, you want your car to be as economic as possible. Yeah, so still it was a pretty good model. I liked how you segregated each and every portion of the MATLAB model. So it was overall a good presentation. Umang sir, do you have any questions?
I think we are good to go.
Alright, so I guess we had one more contestant, Ayush.
Thank you,
Yeah,
sir.
yeah. Thank you, Rohit. But I guess he had an exam or something. Let's wait for 5 minutes if possible. He said he'll be able to join by 6. So in the meanwhile, we can answer the questions if there are any. I don't think so. There are any questions. Or maybe.
Yeah, there are no questions. I also just checked. I thought there are.
Yeah, I guess. Before concluding, I guess I'll have to check with Ayush. Before concluding, how did you all find this competition? Was it competitive? Did it take a lot of time? What sort of thoughts were running in your mind when you took this competition? Did you face any difficulties or anything like that? I guess every participant found it a pretty easy event. If anyone would like to answer, did you find this event challenging? Could there be something else we could do for the challenge? Let's say we are having another event in a few months. What sort of challenge do you think you would expect?
I feel the challenge was like competitive and challenging to a very good point. And obviously, with such a thing where you have to optimize or develop something, the scope is infinity. So it can be ultimate competitive or not competitive at all based on how much you are putting in. So for the 1 week deadlines, everything was very clear, and I feel it was really interesting and very well formed.
So I guess the content provided to you was sufficient enough. Did you find it interesting? Was there something that could have been provided better or anything like that? Any feedback regarding the content or how the competition was being conducted? Yeah. So any of you have you watched the extra content that we gave? The powertrain, how you could model a whole powertrain in MATLAB, not just the battery pack. I guess if you could, Ankit, if you could open your mic and answer, it would be better.
Sir, can you repeat the question?
Yeah. So did you go through the extra content regarding the powertrain sizing that was given to you? How you can size a whole powertrain in MATLAB? I guess there was a few extra content.
Actually, I was busy in some another project also. We are making a Baha vehicle, so I got a lesser time.
Okay, no worries, no worries. So, what I would like you to do is, I would like you to see how you can size a whole powertrain in MATLAB, because it is a very interesting concept. Like MATLAB, many people think it's just for calculations and everything, but if you can size a whole powertrain of an EV in MATLAB in a single software, I think that saves you a lot of time and everything. So, utilize the content that was given to you, and maybe learning this. Sizing of a powertrain could help you not only for a competition like this, but it could benefit you for various other applications in your E project as well. So please ensure that you utilize all the resources that are given to you. I think it will be really helpful to you. And I think the content is really fantastic. It's very easy to understand.
So definitely, I will do on this weekend. I will complete that.
Yeah. So check it out, and if you have any other feedback apart from all of this that you would like to give, that is also welcome.
Sure, sir.
Yeah. So I guess, sir, there is some issue with Ayush. He has an exam. I'll check with him. I'll see his presentation and I will send you a recording so that we can evaluate all the presentations.
Perfect. Sounds like a plan. I think we could do
Yeah. Yeah. I guess then we can conclude this week. Thank you all for joining. Yeah, yeah.
Actually, I couldn't present my screen.
Yeah, yeah.
There is some problem in my system, I think.
Yeah, yeah. Shankar, so regarding your as well, I'll conduct a separate meet. I guess that's a network issue. If you can resolve it and get back to me in the group, right? You're in the IC group. You can get back to me once everything is sorted.
Sir, actually, I am not in the group. I think I am in contact with a person who sent me the link.
Yeah, yeah. Okay, okay. So you can contact Ronak and check if your issue is resolved, and be conducting a meet for you. So you can join that as well, and we can have your presentation there as well.
Okay, sir. Thank you.
Yeah.
Yes, we'll try to do it today itself. So
Yeah,
that
yeah. We'll be
Yes,
ready.
sir. I think 8 o'clock by night it will be
Okay.
fixed because I have actually no power here. So actually the net is pretty bad.
Okay, okay, sure. So I'll take care of this, sir, and I'll share everything, all the details with you, and then we can evaluate all the projects.
perfect.
Thank you.
Yeah, thank you everyone for joining. Each and every one of you had a unique take on your presentation and your listening. So I guess overall this event was a pretty good event for every one of us. So thank you for joining. I hope you all have a nice day.
Thank you so much.
Thank you so much, sir.
All the best.
All the best for your future, guys.
Thank you, sir.